Hi guys, this is just a quick video on a 1994 Jeep Cherokee. No start. It's one that we towed in the back of our tow truck. It has got no spark, so we'll just go through a few basic procedures, see what we can see and what we can't see. Okay, first test we're going to do is to check for secondary spark. It's probably the easiest thing to do. So I'm just going to wind it over, forgive my shaky hands. Here we go. So as you can see, there's no spark coming across the gap. Spark tester. So next test is to see if we've got any switching at the coil. Okay, this is where the coil lives, down in there, and my favourite testing tool. There's the probe light. Hooked up to battery negative, and we're just going to see if we've got any power at the coil. So once again, we're not jamming that into the terminal, we're just placing it in there. Well, these Jeeps have a cutout relay which only supplies power when there's your first switch on the key. I think we saw power there. Bad connection there somewhere. So as you saw then, the probe light glowed, so that means we have got power. The relay switched it off again. So what we're going to do now is go to the other side of that terminal. Obviously that's the switching side, and to check that we're going to go to battery positive, and we should see an earthing switch or flicker, if you will, of the probe light. Okay, so we don't have any switching. So now it's reasonable to assume we have either a crank or a cam fault, or the distributor's not turning, or something stupid like that. It sounds like it's got compression, so we're not going to worry too much about that. Just plug that back in. What we'll do now is just a quick fault code check. These old Jeeps, they do have a diagnostic plug, I think, but none of my scan tools will fit it. It's not OBD2, so there's a manual way you can get it out. I'll show you how to do that. Okay, here we are inside. Now what you do is you cycle the key, switch it on 6 times, and then we'll get a series of codes out. Okay, so here we go. 1, 2, 3, 4, 5, 6, and at this stage we leave it on, and we watch for the flashing of the check engine light. So it goes out. 1, 1, 2, so that's code 12. 1, 1, it's code 11. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, that's all she wrote. So what we'll do is we'll go to the handy code chart and see what 11, 12 and 55 mean. Okay, put my goggles on so I can see what I'm seeing. Now, trouble code 11, that's pretty straightforward. No crank reference signal to computer, check circuit from crankshaft position sensor to PCM. Code 12 was battery disconnected. We see 55, and this thing did have a flat battery as well. 55 is end of code output, so obviously when we see 55 we know that there's no more codes in there, so the one we'll concentrate on is code 11, no crank position sensor signal. We'll show you how we check that. Righto. The crank sensor on these Jeeps, that's the plug for it there, and it lives down on the back or the left hand side of the bell housing as you sit in the driver's seat. The cam sensor is inside the distributor, and there's a similar sort of plug and a 3-wire. They're both appear to be Hall effect sensors. What we're going to do is check to see whether we've got powers, and there'll be a signal wire and an earth wire in each of those plugs. I'm going to shortcut it a little bit because in a Jeep the ECU is right here. So if we check for signals here, the powers and earth's down there, and on the other side we're going to look at the cam sensor as well, because it is possible that you don't believe everything you see from a fault code. So, and if we lose either one of those, it will lose a crank signal. So what we'll do is look at that with a pico scope. So essentially what we are going to do, we're not actually going to do it because I've actually done it already, but this video is probably more, if you are running scopes and stuff, is to see the value of actually using basic test techniques with a scope. Wiring diagrams like this are invaluable. This is one from Autodata. It's very much like a Mitchell's one from the US, but some of the Autodata stuff we see is actually crap because you can't read it. But this is a very, very good wiring diagram. So the wires we're going to concentrate on, I'll go through and say that the powers and the grounds at each of the sensors are good. So these things actually run an 8-volt reference wire as well, or voltage, which is a little bit up on the standard 5-volt, but there's a Jeep. So the two wires we're going to concentrate on are the cam sensor wire, and so that's the ignition coil. We've got a crank sensor, and we have the cam sensor inside the distributor. The camshaft position sensor is the tan and yellow wire, and the crankshaft position sensor is the grey and black wire. So we've got tan and yellow, grey and black. Now, for those of you that use scopes or are thinking about actually getting into scopes, one we run is a Pico 4-channel. It's probably the standard in automotive scopes as far as, I mean, there are really, really good scopes out there, but I think the backup and the in-depth knowledge that Pico has, it's a laptop-based scope. I wouldn't mind at some stage just a handheld scope for basic testing, because all we were looking for is a signal. Essentially that's what we were looking for on a scope. Pardon me, this is real basic, but we saw that on the cam sensor wire, but we did not see that on the crank sensor wire. So all I did then is disconnected the cam sensor terminal. We want to check to make sure that the wiring between here and here is okay, and just a basic check, it doesn't hurt them, scan it in, it does it all the time, is we're going to use the probe light to do that. And all we do is hook the scope into the crank sensor terminal, back probe it at the ECU, or you can disconnect it, it's entirely up to you. If you want to be safer, you can disconnect the plug, and we're going to feed a voltage up through the sensing wire that goes back to the ECU with the probe light, and at the same time we will see the scope react. Essentially that's what we did. So that was a real basic test. It doesn't take very long, and to cut a long story short, it was a faulty crank sensor. We'll go about, well, we're 99% sure, as any mechanic can be. We'll go about now and we'll stick a new sensor in and see what happens. Right, here's the old sensor. As I said, it lives down on the left hand side of the bell housing. They're just sitting in the driver's seat. So I think some Jeeps I've seen on some videos are on the right hand side, but this one lives on the left. So just a couple of bolts and a wiring loom. So we've got that in, plugged everything back up that we had unplugged. Just got to put the cover back on the ECU terminals, but see if it lives. Few knocks and bangs in there, but she's an oldie. Okay, so that is basically it. So I realise that sometimes it's a bit scary with if you can't plug your scan tool in, but all of the original diagnostics that we used to do with anything with the EFI was all watching for flashing lights and putting split pins into things to see if you could get codes out of them, and there was no live data at all. This thing's got a few vacuum leaks with insulation tape around them, and obviously it's going to make it run a little bit rich because it's a map sensor style engine, but we'll get that sorted for them as well. The sensor in New Zealand's a little over $200 plus tax, but I don't know what it's worth in the US. Probably about 25, but that's what we have around here. So yeah, I hope you found something out of that. Forgive my poor work. Next time I will actually give you some shots of the Pico. It's just that I was running out of time a little bit, and I didn't want to spend the time actually filming while I was doing the testing, but I think you'll get the idea. The next one I get, I will actually film while I'm testing, and you can see what you think. Thank you.